Hey guys, welcome to another math video. So for this one I'll be going over the change of base. So I do want to note that there is a change of base for logarithms. I'll be making another video for that, so this is actually something different. Okay, so this is what we'll actually be doing here. So I actually took a course where we did something with the change of base, and a lot of my classmates were having a lot of difficulty, tough time getting through that portion, and that was just like one section. Spent like maybe 2 weeks on it. Okay, so internationally we're using the base 10 system, so we go from 0 or sometimes 1 and we increase incrementally by 1. When we get to 9, our next number is 10. Right, so you're all familiar with that, something that we use every day. Okay, so now in different bases, when you reach your base value becomes a 1, 0. Now I'm saying 1, 0, not 10, because I'm just trying to make that distinction. It'll make a lot more sense when you see what I mean. So here's the numbers here. So in base 6, starting from 0, 1, 2, 3, 4, 5. So the next number would have been a 6. But remember, when we reach our base value, your base value becomes a 1, 0. Okay? So similarly in base 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 1, 0. Okay? So why am I saying 1, 0? Okay, so think of changing base 10 numbers into a different base as like division. Right? So say you wanted to change 0 into base 6. So what we do is we use division. So 0 divided by 6. So if you use long division, you would know that 6 goes into 0 0 times, and you would have a remainder of 0. Similarly, 1, changing into base 6, you would do 1 divided by 6. So 6 goes into 1 0 times, and you'd have a remainder of 1. Okay, 6 in base 6 would be 6 divided by 6, and 6 can go into 6 one time, and you would have a remainder of 0. So that's where that 1, 0 comes from. Okay, so here's our base 10 numbers, 0 to 10. Now 0 in base 6, we mentioned up here, 0, remainder 0. Now we don't have to put that leading 0, that's why we'll only see 0 in base 6 as 0. Okay, 1 in base 6, 0, remainder 1, 2, 0, remainder 2, 3, 0, remainder 3, 4, 0, remainder 4, 5, 0, remainder 5, and here's a 6, remember, we went over that here, 6, 1, remainder 0, so there's that 1, 0. Okay, and that's why I say 1, 0 and not 10. It makes you confused when you say 10 instead of 1, 0. Okay, so 7 in base 6, 1, remainder 1, so I would say this, 1, 1. 8, 1, remainder 2, 9, 1, remainder 3, and 10 is 1, remainder 4. So you can see how people get confused in the changing of base 10 to a different base. Okay, so here's a couple of examples or a comparison of changing into different bases besides base 6 and base 9. So for reference, I got the base 10 here, and I also got base 2, base 5, and base 12. Okay, so going down, you can see how it looks kind of strange for each of these. And on the next slide, I also have it going up to 12, so you can kind of see. So base 12 is where it gets really confusing, because you have to keep in mind that you can only use single values for each number. So when we get up to 10 in base 12, we can't put 10 because that looks like a 1, 0, and you don't use a 1, 0 until you get to your base. Right, so we have to include letters for base 12 to represent 10 and 11 in that base, because 12 in base 12 is 0, 1, 0. Okay? So I hope you haven't been too confused yet. So like base 5 is pretty simple, right? 10 in base 5 is 2 remainder 0, 11 is 2 remainder 1, and so on and so on. Okay? So here's how we change into a different base. So we're the first rule you have to remember is that the values in your converted number cannot be higher than your base. So if you're changing into base 6, none of your numbers in that converted number should be higher than 6. So if you have a 7, 8, 9 in there somewhere, then you didn't convert properly. Okay, and we're going to use repeated division. Values in the new base uses the remainders from each of these divisions. And each new division is going to use the quotient from the previous division as the new dividend. And we're going to keep dividing until our quotient is 0. And this is going to be confusing until we see the example. So each remainder will be going from right to left. So the first remainder will be the rightmost value, and you will put each successive remainder to the left of it. Okay, so let's take a look at an example. Okay, so we're converting this base 10 number, 501, into base 3. So this is where we're starting. So we do a regular division as normal. You divide the number you're converting by the base you want to convert it into. So we're converting it to base 3, so we divide by 3. So 501, you can see we're doing the long division. So here's our quotient, here's our remainder. So our remainder starts on the rightmost side. In the next division, we're using the quotient, and we're still dividing by the same base. Okay, so you go through the long division again. Your next remainder goes to the left of your previous remainder, and you continue this division using the remainders until you get to a quotient of 0. Okay, so once your quotient is 0, you stop. All these remainders are going to be in your answer. Okay, so you can reference this slide as a way of converting from base 10 into a different base. So it's not limited to 3, it's all the different bases. Okay. Okay, so now what if you want to go the other way? You want to convert back to base 10. So what you're going to do is you're going to take each value in the base and you're going to multiply it to the base raised to a particular power. So starting from the rightmost value, you're going to multiply that by the base raised to the power of 0. And each value to the left of that, you're going to multiply it to the base raised to a power 1 more. Okay, so this looks confusing until you actually do the example. And once you have all those set up, you multiply and then you add them all together. Okay, so let's take a look at an example. So we're going to take the base 3 number, 200120 base 3, and convert it back into a base 10 number. Okay, so we're going to start with the leftmost number, multiply it to the base raised to the power of 0. Okay, so that's this one here. Next number is going to be multiplied to the base to the power of 1 more than the last one. So 1 more than 0 is 1. So that's where this came from. Next number, 1 times the base raised to the power of 1 more than the previous one. So you can see each number is getting multiplied to a base with 1 more exponent, yeah, or 1 higher exponent. Okay, so next what we do is we evaluate the exponents. So 3 to the 0 power is 1, 3 to the first power is 3, 3 squared is 9, 27, 81, and 243. Then you just multiply together, yeah, and in all of these products, you just add. Okay, so you can use this as a reference to when you're changing back into a base 10 number, and it works for all different bases. Okay, so if you were in base 6, for example, these would all be 6s instead of 3s. The exponents would still be the same. They'll be increasing by 1 each time for each digit. Okay. Okay, so to sum it up, base 10 numbers you're familiar with. Changing into a different base, we're using division, and you can think of the values in different bases as a quotient with a remainder. So to convert, we're using repeated division. Remainders will be used in your final answer, and we're using each quotient until the final quotient you get to is 0. And each remainder starts from the farther right, and each successive remainder will be to the left of the last one. To convert back to base 10, you multiply each number in the base, each value, each place, by the base raised to the power of 0, and that increases for each value to the left, as you saw in that example we did, and you add them all together. I know that was really confusing, but if you want to go back to the examples and check them out again, they'll make a lot more sense that way. I know you learn this stuff by doing, so do. Alright guys, if you have any questions, and you're doing some problems and you get stuck, you're not sure you're doing it right, post it in the comments. I'll be sure to reply to you, hopefully quickly. If I'm not needing to write anything down, I can probably answer your question pretty quickly. Otherwise, it might take me a couple hours. But otherwise, thanks for tuning in, and stay tuned for my next video. Thanks guys, see you later.